Okay, this is Algebra 1, Section 6.4, and we're going to start talking about exponential growth and decay. So a growth function looks like this, where A is the amount you start with, R is the rate that it's growing in a percent, and remember that to do mathematical calculations, your percent needs to be written as a decimal, and T is the time. So remember growth, we're adding the growth rate, and then the decay function, the only difference, all the letters stand for the same thing. This one is 1 minus r. So think about this. If it's a growth function, that means that whatever number's in parentheses is going to be greater than 1. A decay function, anything in parentheses will be less than 1 because I'm subtracting something from 1. So for example, let's say I have this exponential function. I know it's a growth function because it's more than 1. And I can tell you that the initial amount is 2. And the rate of growth, let's talk about that. So if nothing is growing or decaying, this number in here would be 100%, right? Which is 1. 1 equals 100%. So if this is 0.25 greater than 1, that means it's 25% greater than 100%. So my growth rate is 25%. Okay, so let's look at this problem now. Y equals 2 times 0.6 raised to the t power. Because this number is less than 1, I know this is a decay function, because the number in parentheses is less than 1. The initial amount is 2. And I know that this number in here represents 1 minus r. Okay, so really this number is 60%, isn't it? 0.6 equals 60%. Well, 60% is 40% less than 100%. So my rate of decay is 40%. Again, 1 minus r equals 0.6. So r equals 0.4, which is 40%. The other type of exponential problems you're going to be having in this section is compound interest problems. And if you guys have taken any of Marie's personal finances classes where she's talking about investing or saving or buying a house, you will be familiar with this formula. This is the compound interest formula. P is the principal. That's what you start with. The principal amount usually refers to the amount of money that you got in the loan. R is the rate, again, expressed as a decimal. N is how many times a year that the interest is compounded. And again, T is the time. I forgot to put that here, but T is always time. So let's do this example. You deposit $100 in a savings account that earns 6% annual interest. Remember, 6% is written as 0.06. And it's compounded monthly. So that means it's compounded 12 times a year. Write a function that represents the balance after t years. So you're going to write down the formula always, and then you're going to fill in what you know. So, and then you're going to, you're going to identify the variables. So P is 100, R is 0.06, and N is 12. Now we're going to plug these values into our formula. So that would give us Y equals 100 times the quantity 1 plus 0.06 divided by 12 raised to the 12t power. This in parentheses, do this first, add 1 to it. You get 1.005 raised to the 12t, and we can simplify this one more step. We will be doing that in class. And that is it for 6.4.